Hello, it is Miss Moncrief back at you with a new method of solving a system of equations. And today we are actually learning my favorite. It is the substitution method. It is the substitution method. But before we get into actually learning the cool stuff about the substitution method, let's go ahead and remember a few things. So the first thing we want to remember is without graphing, decide whether the following system of linear equations has one solution, infinitely many solutions, or no solutions. And how do we know? So just so that way we can remember a few things. Let's remember first what it takes to have either of these three options. So in order for it to have one solution, it'll have different slopes, I'm just going to different slopes, and it could have different intercepts, but it doesn't have to. In order for it to have infinitely many solutions, it will have same slope, same intercept. So it's just, they're both the same line. And then in order for it to be no solution, you will have same slopes because they'll be parallel and different intercepts. So let's look at these two lines they gave us. We got y is equal to 3x minus 5 and 6x is equal to 2y plus 10. So we want to write both of these in slope-intercept form, our good old y equals mx plus b, in order to really tell if they have the same slopes, or in order to really tell what their slopes and intercepts are. Because remember, if we have y equals mx plus b, our m is our slope, and our b is our y-intercept. So let's look at them. Let's check the first one. We already know that in the first one we have, the first one is written in let me slow down. Let's check our first equation. We have y is equal to 3x minus 5. We already know that that one is written in slope-intercept form, so there's nothing we have to change about that one. That one's great. Let's look at our second one. It is 6x is equal to 2y plus 10. That one's a little different, right? That one's not written in slope-intercept form, so we got to get it there. So let's rewrite it and get it in slope-intercept form. So we have 6x is equal to 2y plus 10. Now remember, in order for it to be in slope-intercept form, only one variable has to be completely by itself on the equal sign. And what variable is that? You guessed it, that is your y. So everything we need to do has to get y by itself. So remember our lovely little phrase to do reverse order of operations? SAD-MEG. Let's go with SAD-MEG in order to get y by itself. So first we have any subtraction or addition happening to the term with y. Yes, we have this plus 10 right here. So in order to get rid of the plus 10, we will subtract 10. So everybody subtract 10. On the right, that cancels. And we can't simplify 6x and negative 10, so we'll just leave it as 6x minus 10. So we now have 6x minus 10 is equal to 2y. Now, is y by itself yet? No, it's not. So we got to do one more thing to get it alone. That one thing we got to do is what? All right, hopefully you thought about it and you said we need to divide 2. If you're sitting there wondering why we need to divide 2 on both sides, it is because 2 and y are multiplying originally. So in order to get rid of multiplication, we will divide. On the right, they will cancel out. And on the left, we'll divide both terms by it. And then we'll simplify. So what is 6x minus, or 6x divided by 2? All right, and just so that way with consistency, we have the y in the front, I'm going to put y equals. So what is 6x divided by 2? That is 3x. And what is negative 10 divided by 2? That is negative 5. All right, so now that this is written in slope-intercept form, we can go into actually looking at which ones that, how many solutions they have. We can now look into how many solutions they have. So let's look at our first one, our first equation over here. What was my slope? My m. All right, my m was 3. Actually, I want to use these colors that I used up here. My m was 3, and my b was negative 5. Now let's look at the one we just solved. My m over here is 3. So far they have the same slope, so we're down to infinitely many or no solution. And what's my b? Oh my gosh, it's negative 5. So these have the same slope and same y-intercept, so they are the same line, which means they have infinitely many solutions. So the answer to this one is infinitely many solutions, or IMS. This was our answer. And if it wants you to type it all the way out, infinitely many solutions. Those are the two ways you can write or type it out. I don't remember off the top of my head what the lesson online will call for. All right, but that was determining how many solutions it has. Let's now review all of our methods of solving systems of equations. So the first one says recall method number 1, solving by graphing. I also really enjoy graphing just because graphing's fun. So solving by graphing. So that means we will look at our calculators, and I'll slow it down because I know some of you might not be using the same one. So I'll try to slow it down and make sure we all look at the same thing. So we want to look at 5x minus y is equal to 2. And 2x minus 1/2 y is equal to 3. Remember, the most important part here is to first put it in slope-intercept form. On most calculators, you cannot type it in unless it's in slope-intercept form. So it's best to just go ahead and put them that way. Looking at 5, let's start with the 5x minus y is equal to 2. So we have 5x, I want this in black, hold on. 5x minus y is equal to 2. All right, let's again do this lovely sad meg over here. I have 2 terms, right? So I definitely have addition or subtraction. So what are we adding or subtracting to y? This 5x. How are we going to get rid of a plus 5x? Because it's positive. We're going to subtract it. So go ahead and subtract 5x on both sides. And we are left with negative y is equal to negative 5x plus 2 because I want the x in the front. All right? And is my y yet by itself? No. Remember, since there's a negative, there's technically a negative 1 in the front, so we need to divide by a negative 1. So divide both sides and both terms on the second side by negative 1. And we are now left with this equation being y is equal to 5x minus 2. And that is the new rewritten way of our 5x minus y is equal to 2. Now we got to rewrite 2x minus 1/2 y is equal to 3. So we have 2x minus 1/2 y is equal to 3. Alright, so we got to get y by itself. The first thing we're going to do is subtract the 2x. So minus 2x. And now we have negative 1 over 2y is equal to negative 2x plus 3. Alright, and now we got to get rid of this negative 1/2 on the y side. So the way I get rid of fractions when I'm multiplying by them, so we know that negative 1/2 and y are multiplying because they're right next to each other. So in order to get rid of multiplying by a fraction, you normally would divide by that fraction, but I like to say we multiply by the reciprocal. And reciprocal is just the flip version of that fraction. So we're going to multiply both sides of the flip version of negative 1 over 2, which would be negative 2 over 1, or just, how can we write that in an even simpler way? Negative 2. So we're going to multiply both sides by negative 2. And remember, when we're multiplying the entire side by negative 2. Alright, on the left, yes, the left, they cancel. And we are left with y is equal to, and we got to distribute this negative 2 to both terms. So what is negative 2x times negative 2? That is positive 4x. And what is negative 2 times 3? That is negative 6. So we now have y is equal to 5x minus 2, and y is equal to 4x minus 6. So we will now proceed to figure out the solution by graphing. So everyone, hopefully pull out your handy dandy calculator. I'm guessing most of you are either using Calculate 84 or Wabadamoo or something, which is the Android version. But those are the two we strongly suggested getting for our class. Alright, if you have another one, I'm going to hope that it'll be the same way that we do ours. So, what we need to do is first go to the y equals, or wherever your calculator is telling you to put in a graph. So, we now have y is equal to 5x minus 2. Let's put 5x minus 2 in there. 5x minus 2. 5x minus 2. Yours should, 5x minus 2. And then in the y2, we'll put the next one, 4x minus 6. So 4x minus 6. Alright, and then I personally just like to check the graph before going any further. So go ahead and click graph. Make sure we see it. Right now, we don't see the point of intersection, and that's okay. If we wanted to, we could zoom out, but we can still just find it without having to zoom out or anything. So let's go ahead and find it. If you're using the calculator that's like the TI-84, you'll click second, which is the blue button. You'll click trace, and then you'll go down to option number 5 and click intercept. Most calculators should have some form, most graphing calculators should have some way of finding this intersection point. You might have, if you don't have the Calculate 84 or Wabadamoo, you might have to play around with whatever calculator you have. Alright, but go down to the intersect. Alright, we need to be on the first curve. Are we on the first curve? Yes, click enter. Are we on the second curve? Yes, click enter. Some calculators don't have this guess option, but if you have the guess option, just click enter through it. Your answer will be at this part that says intersection. This will be your answer. This will be your answer. So what is my answer? Negative 4, 22. So my answer is negative 4, negative 22. I bet some of you are calling me out right there at home watching this, which makes me happy. Yes, pay attention to your signs. It's -4, 22. And remember, all answers to a system of equation have to be written in an ordered pair. Also, don't forget your parentheses and your commas when you were doing this. If you just write it as -4, -22, I have no idea what you're talking about. If you put I personally think you're talking about -4 minus 22. I'm like, that doesn't make any sense to me. Also, make sure you have this what most of you are doing when I'm looking at tests is you'll have the -4, the comma, and the -22, but you'll forget the parentheses on the end. Put the parentheses on the end. Just make sure you do it. So yeah, your answer is -4, 22. Sorry for the little rant, but just wanted to help you out. Anyways, that is how we do it by graphing. I hope your calculator also got you -4, -22. All right, now we want to look at the next method, solving using the equal values method, which is also a great method for solving a system of equations. You can just tell I just really like solving systems of equations. So equal values method. Anyways, it says the graph shows the balances of two bank accounts over time. Use the graph to write a system of equations giving the amounts in each account over time. Let T equal the time in weeks and B equal the balance. So, we first got to write two equations here. So, let's do that. Let's start with which line do we want to start with? I guess we'll do account 1, the blue line. So, looking at the blue line, we got to, in order to write equations, and we want to write them in slope-intercept form, we need to have my M and my B. So my M and my B of my blue line, let's find them. All right, the first one we could find was definitely our B. It was right here. What was it? It was $40. Very good. So that means they just had $40 in their bank account early. So now let's find my rise over my run. So we go up what looks to be 1, right? Well, looks to be only 1 block. But what's the distance between these? I go 40, middle blank, 60. This is overall 20, so that halfway point is probably 10. So I go up 10. And now I need to figure out how many I run. I run. So we go 1, 2, 3, 4. And yeah, so 4. So that means my slope for the blue line is 10 over 4, or we can simplify that by dividing both the top and the bottom by 2, 5 over 2. So my equation for the blue line for account 1 is y is equal to 5 over 2x plus 40. All right, very good. We have my first equation. But is that enough to figure out the rest of it? No, it's not. So now let's find the next equation. The orange one. Let's find my M and my B of my orange line. Oh, wait. I forgot something. And none of you were here to call me out on it. Remember, we also need to replace my y and my x with different variables this time. We are replacing them with T and B. T stood for time in weeks, so is that X or Y? You're right, that was X, so we have 5 over 2T, and B stood for balance, so my Y will be B. So my real equation is B is equal to 5 over 2T plus 40. I'm sure had all of you been right in front of me, you would have been like, Miss Moncrief, you got to change that to B and T. All right, anyways, now let's move on to my M and my B, which is not the balance B, but my initial value B of this second equation. All right, so where do I cross the y-axis on this orange line? Oh, that one's easier. Cross it at 0. How nice. All right, now let's find my slope. How much does it go up? 1, 2. So that is 20. And how much does it go over? 1, 2, 3, 4. So now we have 20 over 4. So m is equal to 20 over 4. And can I simplify 20 over 4? Yes, that would go out to 5. All right, so my new equation using b and t this time will be b is equal to 5t. And remember, we don't have to put the plus 0 for the we don't have to put the plus 0 for the intercept when we're writing it out in an equation. So now we want to go solve this through equal values method. So in order to solve an equals value method, we just got to set these two equations equal to one another. The kind of way of thinking about that is replacing one of the b's with what the other one was equal to. It's just, yeah, so they're both equal to b right now. We're just going to replace the b's with each other. So you can have 5 over 2t plus 40 is equal to 5t. It's equal to 5t. All right, and now we just have to solve this like any normal equation. So let's start by getting the t's on the same side. I'm going to move this t because it's because this t has nothing over here with it. So if I'm going to move this t to the t with the 5t, to the side with the 5t. So in order to do that, I'm going to subtract 5 over 2t from both sides. What happens on the left? It cancels. And then sometimes even subtracting these numbers for me can get hard. So I can do 5 minus alpha y equal 1, 5 over 2, and I get 5 over 2. I get 5 over 2. What is 5 over 2? Why am I perplexed by this? Oh yeah, that makes sense. All right, so we now have 40 is equal to 5 over 2 t. And we still got to get this t by itself. So remember up here, when I said we needed to get rid of this negative 1/2 because we were multiplying by it, I said, hey, let's multiply by the reciprocal. So in this case, we're going to multiply by the reciprocal of 5 over 2. And what is the reciprocal of 5 over 2, everybody? You're right. It is 2 over 5. 2 over 5. And what happens on the right? It cancels. And then we just got to figure out what 2 over 5 times 40 is. So alpha y equals 1, 2 over 5 times 40. And what do we get? 16. So t is equal to 16, which really just means what? If the account continues to grow as shown, when will they have the same balance? Well, t was what? Weeks. So that means that 16 weeks. 16 weeks they will have the same balance. Remember, you were given units, so you have to give units. All right, and now I want to know what the balance will be. I'm hoping you're all remembering how I can find that b once I have a t. We'll just plug it into these equations. So we'll do, which one do you want to use, the first one or the second one? Personally, I would use the second one because it doesn't have an initial value and all we're doing is multiplying by 5. So yeah, let's use the second one. Whoever had that idea was great. So let's use the second one. So we have b is equal to 5 times 16. And what do we get when we multiply 5 times 16? We get 80, so B is equal to 80. And what is the unit? What will the balance be? 80? 80 what, guys? Pennies, quarters, dollars. $80. Wow, I could use $80 right now. Anyways, moving on. That is how you solve using the equal values method. So now let's get to the fun stuff. And also, real quick, if I wanted to write that as an ordered pair, how would I write it? 16, comma, 80. There we go. Just one quick check. All right, but now let's get into substitution. My favorite part of what we're doing today, the substitution method. So, solving by substitution, like equal value method, it eliminates a variable so that you only need to solve a one variable equation, which are so much easier. So now look for an equation that is already solved for one variable or it can easily be solved. Let's take a look at example 1a and see what that's really talking about. So we were given y is equal to negative x minus 7 and 5x plus 3x, or 5y plus 3x is equal to negative 13. So when it's said here, look for an equation that is already solved for one variable or can easily be solved by one variable. What it meant was, let's see if we have one equation that already has just one variable all by its lonesome. So between these two, do we have one variable that is on its own side with nothing else connected to it? It's just that, then equals, or equals, then that. We do. We have this y is equal to negative x minus 7. So, since we have this one, all we'll do is anywhere we see y in the next one, we will plug this in. We will plug the other side of the equal sign in. That equal sign is saying y is that. Kind of. So y is negative x plus 7. So anywhere we see y, we can replace it with negative x plus 7. So where do you see y in 5y plus 3x is equal to negative 13? Let's see it right here. So one thing I strongly suggest doing is writing out the number, then putting parentheses, writing out the second equation that you're going to use, that you're going to replace the variable with what was behind the equal sign, is writing it out without the variable and putting parentheses in its place. So 5 parentheses plus 3x is equal to negative 13. And then inside that parentheses is where you'll put the negative x minus 7. Alright, so we now have this step. 5 times negative x minus 7 is equal to 3x minus 13. So this is something that we've seen solved before and we could easily do it. Our first step is, of course, to distribute this negative 5 so that way we can get rid of this parentheses. And then we're left with negative 5x minus 35 plus 3x is equal to negative 13. You've seen something like this before. Do we have terms that we can combine? Oh, yes, we do. We have this negative 5x plus a 3x. What is negative 5x plus 3x again? That would be right here at negative 2x. And so we have negative 2x minus 35 is equal to 13. And now we are ready to do reverse order of operations, or SAD-MEG, in order to solve for x. So if I have negative 2x minus 35 is equal to negative 13, what's going to be my first step to get that x by itself? Do I have any subtraction or addition happening to that term with the x? Yes, I have a minus 35. How do I get rid of a minus 35? That's right, you add 35 to both sides. And that will get you negative 2x is equal to 22. So how do I get rid of this negative 2? Well, they're multiplying, so then we will do division. Divide both sides by negative 22. And now we're left with x is equal to negative 11. Since we have x now, much like when we had t in my example for, or t in my recall for equal values method, since I have x, I will now plug it into one of these equations and find y. Again, it's going to be easier if we plug it into the first one because it's already solved for y. So, all we will do is do the same thing. Y is equal to negative, because we have a negative. What did I get for x? Negative 11 minus 7. Plug that in your calculator. Negative 11 minus 7. And what do we get, everybody? We get 4. And the crowd goes wild. So we know y is equal to 4. And since we now have my x and my y, we can put it in our ordered pairs. Negative 11 and 4. And that's the substitution method. It is finding something that is already equal to one variable and plugging it into this other equation. Let's look at a couple more examples. Alright, so example 1b, we have x minus 2y is equal to 8, and then we have x is equal to 5 minus y. Now I know what some of you might be thinking. That 8 is over there all by itself. Can I replace it? No, don't even think that. We only need to see when a variable is by itself. A variable. 8 is a number. So, in my first one, x minus 2y is equal to 8 is a variable by itself. No. So move on to the next one. See a variable by itself in the next one. I have x is equal to 5 minus y is a variable by itself. Is it? Yes, it is. X is by itself. So that means we can replace x in my other equation with this 5 minus y. And you kind of see that here drawn throughout the arrows. We separated them. We have x minus 2y is equal to 8, and x is equal to 5 minus y. All we're doing is taking this 5 minus y and putting it where we have x. Gross, that was a bad arrow. This is 5 minus y and putting it where we'll have x. Once we do that, it'll look more like this. 5 minus y minus 2y is equal to 8. We put this example in because we know that we have a hard time saying let's use x. We kind of want to always use y, but we have x, so let's go with x. So, now we have this parentheses 5 minus y minus 2y is equal to 8. So, we need to now drop the parentheses, so that way we can combine like terms. We have 5 minus y minus 2y is equal to 8. Is there any like terms we can combine? Yes, we have negative y and negative 2y, which gets me negative 3y. So I now have 5 minus 3y is equal to 8. And here's where sad Meg comes in again. So, do I have any subtraction or addition happening to the term with y? Yes, I have this plus 5, so I will subtract 5 on both sides. And which leaves me with negative 3y is equal to, what is 8 minus 5? 3. So, and then I need to divide by the negative 3 in order to get y by itself, which leaves us with y is equal to negative 1, which is again right here. I just wrote it out with all the steps in case anyone was wondering how we got the negative 1. So now that I have y is negative 1, I can plug it back into this equation up top in order to find x. So I have x is equal to 5 minus a negative 1. So minus a negative makes that positive. So I have x is equal to 5 plus 1, which is 6. All right, so that's just a couple of examples to walk through. Let's do these two really quick so that, let's just do these two really quick. We have two more. So I have example 1C, 2C, I don't remember the number, but example C. We have 4y is equal to x, and 3x minus y is equal to 7. First question you need to ask yourself, do we have a variable that is by its lonesome? We have 4y is equal to x, and 3x minus y is equal to 7. I see a variable that's by itself. Which one is it? X! X is by itself. So wherever we see x, we can now plug in the other equation. We can now plug in 4y. We can now plug in 4y. I see 1x right here. So we can do, move. You're in my way. We can do 3 times, what did I say we can plug in for x again, everybody? 4y minus y is equal to 7. And now we should be pretty good at figuring out how to solve for y. We first need to distribute, right? What is 3 times 4y? 12y. So we have 12y minus y is equal to 7. What is 12y minus y? 11y. So we have 11y is equal to 7. And now we got to solve for y. 11 and y are multiplying by one another, so that means we need to divide by 11 in order to get y by itself. So we have y is equal to 7 over 11. Y is equal to 7 over 11. That fraction doesn't simplify, so we don't have to change anything about it. All right, so now that we have y, we can plug this 7 over 11 in back to our first equation that we have x is equal to. You don't have to plug it into that one, but I personally think that one's going to be easier. So now we have 4 times, what did I get for y? 7 over 11 is equal to x. And we can just plug this in our calculator and figure that out. So alpha y equal, oh wait, no, I don't need to do that. Second mode. So 4 alpha y equal 1. Oh no, never mind. Let's do that. Oh, let's do 4 times alpha y equal 1 and 7 over 11. And what do we get? We get 28 over 11 is equal to x. So my solution is going to be, what is my x? 28 over 11, comma, what is my y? 7 over 11. I know a lot of us freak out once we see weird fractions and decimals as answers, but it can work. This can be a solution. So don't freak out. Just let it be. All right, now let's look at D. D is a little different from all the ones that we've seen. We have 2x minus 7y is equal to 7, and 6x minus y is equal to 1. Take a look at those and tell me if they have a variable by itself. No, they don't. So we have to solve one of them for a variable. Let's look. Let's look. In the first one, we have 2x, and we have negative 7y. In the second one, we have 6x and negative y. So, the easiest ones to solve for that variable are the ones who have a coefficient of 1. This one has a coefficient of 2. This one has a coefficient of negative 7. This one has a coefficient of 6, and this one has a coefficient of negative. But what is that number when you don't see it? 1. So right here, it is going to be easiest to solve for this y. So let's take this second equation and solve for y. So we have 6x minus y is equal to 1. What's the first thing we got to do in order to get y by itself? That's right, we have to subtract 6x. What happens on the left? Cancels, and now we have negative y is equal to negative 6x plus 1. Alright, and now y is still not by itself. We have to get rid of that negative. So we need to divide everything by a negative 1. And this is also a 1. My handwriting got bad right there. What happens on the left? It cancels, so we're left with y. And then it changes the sign of everything on the other side. So we got 6x minus 1. Alright, so now that we've changed this equation, do we now have a variable that is completely on its own? Yes, we have this y that is completely on its own. So that means we can plug 6x minus 1 into the first equation wherever we see y, which would be right here. So we now have 2x minus 7 times, what did I say we're going to plug in for y? 6x minus 1 is equal to 7. Alright, and now here's the part where we just solve for x. So the first thing we got to do is, of course, distribute this negative 7. So we have 2x. And then what is, my brain's gone kaput. What is 7 times 6? 2x minus 42x plus 7 is equal to 7. So let's combine like terms. What is 2x minus 42x? That is a negative 40x. So negative 40x plus 7 is equal to 7. All right, now it's time for the SADMAG. Time for those inverse operations. Do we have any addition or subtraction happening to x? You're right, we have a plus 7. How are we going to get rid of a plus 7? We are going to subtract 7 from both sides. What happens on the left? It cancels, and then 7 minus 7 is just 0. So we have 0 is equal to negative 40x, or negative 40x is equal to 0. Alright, negative 40 and x are multiplying by one another, so in order to get rid of multiplication, we will divide. So let's go ahead and divide both sides by negative 40. And what is 0 divided by negative 40? What is it, everybody? You're right, it is 0. So we have x is equal to what? 0. Alright, so now we got to figure out y. So in order to figure out y, all we got to do is plug in x. Now, we have 3 equations we can plug in x. I bet some of you are like, what, Miss Moncrief? We were only given 2. Right, we were given 2x minus 7, y is equal to 7. Or we were given 6x minus x, or 6x minus y is equal to 1. But didn't I change that one? Yeah, I changed it to y is equal to 6x minus 1. So there's my third option. Let's go ahead and plug it into the third option that we solved for y, because that is going to be the easiest. So we have y is equal to 6 times 0 minus 1. What is 6 times 0? It's 0, so y is equal to 0 minus 1. What is 0 minus 1? Y is equal to negative 1. And now that we have an x and a y, we can create an ordered pair of 0, negative 1. And that is your solution. So you now have all the practice you can work on. I think it's 1 through, oh my gosh, it's 1 through 14, 1 through 14. If you have any questions, you can email your teacher. I hope you enjoyed this video. I hope you are enjoying I hope you enjoyed substitution. I hope you are enjoying system of equations. If you have any questions, you can email your teachers, and I hope you have a lovely, lovely day. Goodbye.